All right, it's recording. Here we go. We're now moving on to exercise 9B. If you've forgotten, I told you the timeline is we're going to start on 9B just this term, and then the rest of chapter 9 will be in term 4. Okay, so your main objective for Tuesday coming, if you've forgotten, progress test on chapter 7, okay, is on Tuesday. That is to do with everything to do with B, C, D, okay, solving, and then you got E and G applications, yeah? Today, we're going to do 9B. So grab out a pen or pencil. Let's revise some things that we know about coordinates. Here we go. Plotting coordinates. Write this down. Coordinates. Boys, we're not speaking while I'm speaking. That's disrespectful. Here we go. Plotting coordinates. You have an X and a Y. Write that in. So X comes first before Y. And the logic to it is that in primary school, you started off learning number lines, right? You counted 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Year 7, you then learnt negative numbers. So it would have looked like something like this. You would have started off counting in primary school that way. So 0 to 100 and onwards. Then in year 7, yeah. It is now re-recording again. Okay, here we go. So you learnt in primary school how to count from 0 to 100 onwards. Then in year 7, you learn to count negative numbers, so you go in that direction. So that's one number line, right? When it comes to coordinates, boys, you're doing it again. Don't be disrespectful. And if you can't be quiet, I'm going to ask you to go outside. Okay, so here we go. Then now you've got two number lines. We've got now a vertical number line where you can go positive this direction. So this is, whoops, let me just do that again. And let's color that again. So this is now the positive for the second number line. And then when you go down, that is the negative version. Now we call this your Y number line. And this is your X number line, or better known as, and this is what you're going to fill in. Your two number lines are your X-axis and your Y-axis. So there are two number lines there. And so therefore, when you write a coordinate, it tells you which point on that plane, or this is called the Cartesian plane, on that plane, where are you specifically, right? So here's some examples. Let's plot in the coordinate for 1, 3. So when they say 1, 3, what I'm actually doing is I'm looking at X number line. So look at the X number line first. So that's the horizontal line. Look for 1. So here's 1. 1 is over here. This is where 1 is. So 1's over there. But then I need to look at my second number line, which is the Y-axis, and that's number 3. So I count it, I go, okay, on the Y-axis, it's 1, 2, and 3. This is where 3 is. So together, this is where the 3 is. That's the line for 3. This is the line for 1. So where do they both intersect? Well, they both intersect right at this specific point. This is the coordinate where your X is 1, but then your Y coordinate is 3. That is why we say this point is 1, 3. See, thanks. That's my third warning there. Yeah. Third warning. Yeah. So the next time I say your name again, you're going outside. Okay? There we go. 1, 3. Let's plot these next few coordinates. -5, I'm going to give you, what's this? You got 4 coordinates there. I want you to plot the next 4 coordinates in, give it about, let's go 1 minute. 1 minute, I want you to plot -5, -7, -1, 8, and 0, -1, and see if you've got the correct spot. The 2 coordinates I'm interested in later on is the 0, -1, and 6, 0, because there's something special about it, which leads on to next term. But those are going to be your 2 key points, okay? So plot it in. You got 1 minute. You got 1 minute, boys, unless you've already plotted the coordinates. All right, let's see. It's about another 20 seconds. He had an injured hand. Let's go to the sick bay. Do you want to go sick bay? All right, here we go. 20 seconds over. Let's go. Check your answers. -5, -7. So here's -5 on the x-axis. Negative 7 takes me down here. So negative 7 is now further down here. So together, where do they both intersect? It intersects right at this particular point right there. So this point here would be negative 5, negative 7. Okay, so I've got negative 5 on the x, negative 7 on the y. Next one, negative 1, 8. So negative 1 is over here. This is where negative 1 is. And then I'm going all the way to 8. This is 6, 7, and then 8 is over here. So this is my coordinate for negative 1, 8. Let's have a look at your last two special ones. I'm going to use the green color to show you them how they're different. When we say x is 0, a lot of students don't realize, but x0 is actually just at the center. That's where 0 is, because this is your x-axis. So 0 must be right at the center of that x-axis. So you're at 0, not moving left or right, and then you're moving up or down. In this case, you're moving down by negative 1. Okay, so that's why we know the coordinate for the green spot is negative 1, which is over here. That's the spot for 0, negative 1. Okay, so you're not moving left or right because the x-axis is 0. Whereas on the other one, this one is saying you're going to move to the right by 6, but then you're not moving up or down. You're staying at the origin. So in that case, where would that be? I'm moving across all the way to 6, which is right here. That's where my 6 is. And I'm not moving up or down, so I stay right on the x-axis. Now there's two special names for these two coordinates. So one is 6, 0, and the other one is 0, negative 1. I want you to draw an arrow because this will link to next term's notes. This is normally called your x-intercept. So write that in. And this one is called your y-intercept. And what we're saying there is that you've got a coordinate on the y-axis, then we call it the y-intercept. If you have a coordinate on the x-axis, then it's called the x-intercept. Okay, so just fill that in. Just some notes to have a language. Now today's lesson, first skill was, can you plot coordinates? That's the first thing. But really, how does this tie with algebra? Gabe, outside for a moment. Thank you. 30 seconds and then come back in. Here we go. So, how does this tie to algebra? Algebra. Thanks, team. I'm actually a bit annoyed. So, Ronan and Balan, you know my lessons. It's on Friday, session 4. Doesn't mean while I'm speaking, you don't speak. You actively listen or you actively take notes. Yeah? Here we go. So, how does this rely back onto algebra? It comes back to pattern recognition. So what I want you to do is, when you think about coordinates, right, they're just dot points. If I gave you this picture, and don't draw this in, if I gave you this set of coordinates, tell me what you see, all right? What pattern do you see? You see a smiley face. Now, all I did was, you technically could replicate all of these. These are dot points, coordinates. So there's a pattern that you can see. Now, what we're specifically looking at in chapter 9 is a specific pattern. And the pattern is that when the coordinates look like this, what do you see there? A line. So this is called linear relations because we're linking the pattern of coordinates. What are the patterns that you can see that makes it a straight line? So I'm going to show you soon, but we're going to start off very simple. Let's look at this. See the first set of coordinates I've got for you. I've got 0, 1, 1, 2, 2, 3, 3, 4. There's a pattern to it. What's the pattern? If I told you this was 19, what should the y coordinate be? Have a think. Look at the pattern. So when x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 3. When x is 3, y is 4. What is the pattern? Okay, I just want to know the answer first. What's the answer? 20. Now, this is where I want you to do a bit of thinking and modeling. You can come back now, Gabe. Thank you. So you know the answer is 20 through logic. There's something that's going through your head that no matter what number I tell you now, even if I chose 100, if I said x was 100, what would the y coordinate be? 101. So you're doing something in your head right now. There is a formula that you're following, and you figured out it was 101. So what was that formula that you came up in your head right now for y? What did you say to yourself? How did you know it was 101 if I told you it was 100? What did you do? Okay, what did you plus 1 to? To the x. So when we write the rule, what you're really saying is to find all the y coordinates, the pattern was whatever x is, add 1. Can you please write that down? So this is a rule. This is teaching you to recognize that I can actually figure out what the pattern is based on what you were able to predict, because you can see a pattern, right? So you can see a pattern now. You can see y equals x plus 1. You were able to predict what would the y have to be in order for that rule to work. Now let's go to the next one. Let's look at the next pattern. You just came back, Gabe. Okay. I want to continue teaching. I don't know what you guys continue doing, but please actively take notes or actively listening. Here we go. We've got next set of coordinates, you've got 0, 0, 1, 2, 2, 4, 3, 6. So when x is 0, y is 0. When x is 1, y is 2. When x is 2, then the y will be 4. When x is 3, y is 6. You should see a pattern. What's the pattern? Yeah, so the pattern here is that if I told you this was 21, hopefully you realize all I did was I doubled whatever x was. So double of 1 is 2. Double of 2 is 4. Double of 3 is 6. So there's a pattern. The pattern was if I know x is 21, double of 21 was 42. So what's the rule? The rule was that whatever you want y to be, it is x times 2. Now I want you to write this down. What's another way of writing x times 2 again? 2x, very good. So your rule turns out to be this. Y equals to 2x. Okay, can you see how it's starting to relate to algebra? Because you're now hypothetically saying, I don't know what x is, but if I do, I know what the y coordinate is based on this rule. That's where algebra comes in. Okay, now, so that was the first part of your exercise. First one was plotting coordinates. Second one is, can you see a pattern to the coordinates? Once you can, well, sometimes they're too lazy to write it like this. See, they can't be bothered to write it like this every single time. There's just too many brackets. It gets very tiring, gets very confusing. So what we use instead is we use a table to summarize it. See, each one had an x. There's an x, 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 x. So why don't we just write x once, and we just write 1, 2, 3, 4, 19. Same idea, but it's in a table. This is called a table of values. I want you to do the same thing again. What's the pattern? When x is 1, then you get y is equal to 4. When x is 2, y is equal to 5. When x is 3, y is equal to 6. When x is 4, y is equal to 7. What's the pattern? Is it? You're right too. It is 2. So that means if x is 19, then y must be? Yep. And so what's 19 plus 3? Very good. So the answer here would have been 22. So what I want you to see is you figured out the rule just now. You said it had to be whatever x was, add 3. Thanks, boys. This is your rule. You figured out a rule for it. And if you don't realize here, these are actually coordinates right now. You're saying when x is 1, y is 4. When x is 2, y is 5. When x is 3, y is 6, according to the rule. And when x is 4, y is 7. And when x is 19, y is 22. These are your set of coordinates, but this is a much easier way to write it if you put it into a table. So the second part of the exercise was, can you read the coordinates from a table? Sure. All right, so you've got now, I'm just going to fill out all this again. You've got now x equals 2, x equals 5. I'm just going to rub all this out so you don't get confused, and that's 22. Here we go. Now let's tie all of this together and let's visualize. I'm going to show you something cool on Desmos so you can see how it relates back to algebra. This is what you're going to do. Flip over to the next page because the next one is just 2x again. But I want you to flip over to the next page, and this is our last example to tie everything together. Turn over to the next page. Thank you. I can tell you're not copying notes if you're not turning over the page. We're on to the next page now. Turn over to the next page. Here we go. We've got our rule. They tell us that y equals 2x plus 4. This is our rule now. Welcome back. We've got y equals 2x plus 4. I want you to fill out the table if you know this is the rule to find out your y coordinates for each one. What would the y coordinates be? Now start off with the positive numbers first before you do the negative numbers. You've got, let's go 221. Let's add 2 minutes. 2 minutes. I want you to fill out the table if you're given the rule. The rule is y will equal to double of x and then you add 4. Double of x, add 4. I'll do the first one for you. If x was 0, double of 0, and then you add 4. Double of 0, 0. Add on 4. You now have 4. So y equals 4 here. I want you to fill out the next few spaces. What are the next few values? Let's go. What are the next few values? So according to the rule, it says whatever x is, double it, add 4. Whatever x is, double it, add 4. So right now they're saying x is negative 3, x is negative 2, x is 0, x is 2, x is 3. Find out y. The y rule was double x, and then you add 4. I do the second one. Double of 2, add 4. You get 8 for the second one. Let's do the next one, last one. Double of 3, add 4. Double of 3 is 6. 6 plus 4 is 10. Sorry, boys. I know whatever you're doing right now is not copying notes and not actively listening. If you're going to be sorry, please don't do it again. Thank you. Otherwise, your words mean nothing. We're on to negative 3 and negative 2. Now, I left the negatives because I was unsure if you're okay with negative numbers. If you're not okay with negative numbers, I'm going to do it over here again. So y equals double of negative 2. What's double of negative 2? Negative 4. Add 4 gives you? 0. Very good. So this one is 0. And then let's do the next one, negative 3. If you're going to double negative 3, what's double of negative 3? Negative 6. Add 4 though? Negative 2. Very good. So this should be negative 2. Now let's write out the coordinates. So you've got a rule. This was your rule. We're going to write the coordinates out. You've got negative 3, negative 2. That's what this represents. This is your second one, negative 2, 0. Here's your third coordinate. Here's your fourth coordinate, 2, 8. And your last coordinate is 3, 10. Now what I'm going to teach you and why a lot of students at year 9 start to give up at this point. You see, when I guided you through, it's not hard. It's just understanding what is this whole thing. What are we actually trying to replicate? And I talked about the pattern of coordinates. Right now, you can plot these coordinates and then you can tell me what pattern you should see. I'm going to give you 2 minutes. Can you please plot those 5 coordinates and tell me what pattern you see? So pattern on the bottom, can you just write, what is the pattern that you see if you plot all 5 coordinates? Let's go. Negative 3, negative 2, negative 2, 0. See what pattern you get. It is a linear line. Do you know what the y-intercept and x-intercept would be? Very good. And I'm going to show you a Desmos to visualize this. So today's lesson is really just familiarizing with coordinates. How do you plot coordinates on a Cartesian plane? How do you recognize a pattern? And can you read it from a table? Just 3 things. That's exercise 9B. 9B is to practice plotting coordinates, reading a pattern, reading a pattern, and then reading it from a table. So I'm going to plot the coordinates now. So those who are actually attempting to put this onto the plane, let's check your answers. -3, -2. Got 1 point. -2, 0. 0, 4. 2, 8. And lastly, 3, 10. If you did this correctly, if you use a ruler, it should sketch out very nicely to be a nice straight line. Boys, girls, thanks team. Shh. Settle down. Thank you, team. I'm still explaining. I'm still waiting. I'm going to pause the video. Recording again. Yeah, it is recording again. All right. Here's the idea. Desmos, if you've never used it before, is a really powerful tool for those who aren't strong in algebra, but it helps you visualize. Go to Google, and then you type in DESMOS, okay, Desmos. It's the first one here, says graphing calculator. And what it does is it helps my students who aren't yet able to visualize an equation. So you guys were able to come up with a pattern and a rule. But you see that rule that we just did, y equals 2XX and add 4. This was the pattern. It's a linear pattern that you can see. Now the 5 coordinates you listed before, you had -3, -2, so -3, comma, -2. You see, it's not by accident that it actually sits on the line. It's mathematical because you're actually calculating a pattern. If I said the next one, the pattern was double x and then add on 4, you told me when it's -2, it should be 0. And again, it sits on the line. See, that's not by accident. -2, 0 sits on that line. So there's some power here that if you know a rule, you can do a prediction. Now the rule says double whatever x is, you're going to double it and then add 4. So if I told you, what if x was 100? Double of 100 gives you 200, and you add 4 to it, that gives you 204. So what that tells me, boys, don't do it again. That tells you that the prediction is, I can predict, even though it's not on the screen, I can predict that when x is 100, the y value should be 204. That's the pattern. So if I zoom out now, even though I didn't see it before, I can tell it will sit on the line at 100 and 204. It's not a guess. It's mathematical. And if when you're playing games or you're thinking about like a mathematical situation, this could be your hourly rate. This could be that you get $2 every hour, but if you come to school, you get $4. So if I said, well, if you spend 100 hours, how much money would you get? That is a calculation of what you could do to predict. You can calculate something that's constant. That's why it's called a linear pattern. That's what we're doing. We're getting you to think, well, how does algebra apply to something that you do daily? You could be thinking about how long it takes to drive here. If it takes you 30 minutes to drive to school every single day, well, I can say, well, in 10 days, how many hours have you spent? You can figure out how much that is. If you want to say for an iPhone, you can also figure out, well, if you're earning $14 an hour and each week you spend, I don't know, $5, how many weeks will it take before you can buy an iPhone? So here's an example of the rule. If you're earning, so I'll do Y is how much you earn. Say you earn $14, so $14 per hour, so times X. That's the amount of hours that you work. And you spend $5 per week. Let's work it. That's your pattern. So looking at this graph now, depending on how much it costs to get your iPhone. Now, how much does an iPhone normally cost at the moment?
Which one? 1400.
I don't know, the latest one.
1400.
1400. All right, 1400. So Y equals 1400. Now, if I do that, if I zoom out, that's where 1400 is. This intersection, that is how long it will take for you to figure out right at this point, right there, that tells me, if I look at that coordinate there, what this is actually telling you is that $1,400 for an iPhone, and if you minus $5 every week, and you work, I don't know how many hours each week, that's what we're trying to figure out, at $14 per hour, that tells me you need to work 100.35 hours per week to make sure that you will earn that much by that time. But can you see what I'm doing? I'm applying something, but you can't apply if you don't understand algebra and you can't problem solve. That's why we're teaching the basics. So when people say, well, how does algebra apply to my life? Well, it depends on how much practice and thinking you do. So you can use them. That's the idea. But where do you start? You start with the basics. Learn to plot coordinates, learn to find a pattern. That's what chapter 9 is about. Okay, so you'll find that chapter 9 may feel very, very intense. So what I just did there, that might look confusing to you, but I'm illustrating a point that you can do. Okay, so chapter 9, next term will get tricky, and next year, year 9 is one of the first points that I find year 9 starts to give up. It's one of the key things. So build your algebra, 7B, 7C, 7D. Make sure that's your prerequisite skill, because then it helps you to at least pick up the things I was just saying just now. Okay? So please, this session now, it's 2:34. You got about, what's that, 40, 35 plus 15, about more than 40 minutes to practice chapter 7. 7B, C, D is what I want you to work on. I'm here to help out on chapter 7. 9B is only if you're up to date. If you're up to date, you can have a look at chapter 9 and look at coordinates. Okay, team?